Assalamu alaikum warahmatullahi wabarakatuh. Class 8, we have completed the explanation of chapter number 7. So today we are going to discuss the short question answers. Question number 1 is, how does sound travel in air? Now start answer number 1 from here. In place of it, write down an object. When an object is made to vibrate, particles of the medium, that is air, are disturbed from their mean positions. These particles exert a force on the neighboring particles and set them into motion. This process continues in the air till the sound of vibrating object reaches our ears up to here. In place of tuning fork, write down object. Now question number 2 is, what are longitudinal waves? The wave in which the particles of a medium vibrate to and fro or back and forth along the direction of propagation of wave is called a longitudinal wave. Sound waves are longitudinal waves. Now question number 3 is, derive the relationship between time period and frequency. Now relationship between time period and frequency. We know that time taken by a particle to complete one vibration is called the time period. Therefore number of vibrations in t seconds equals to 1. Number of vibrations in 1 second equals to 1 upon t. We know that the number of vibrations in 1 second is called frequency, hence f equals to 1 upon t, where t is equal to time period and f is equal to frequency. Question number 4, how does a loud sound differ from a soft sound? Draw diagrams. The loudness of a sound depends on the amplitude of vibration of a vibrating object. The larger the amplitude, the louder is the sound produced, and the smaller the amplitude, the softer is the sound produced. And these are the diagrams for soft sound and loud sound. Draw a diagram to show the wave distribution of high-pitched sound and low-pitched sound but of the same loudness. These are the diagrams for low-pitched sound and high-pitched sound of the same loudness. Now long question answers. Question number 1, describe the formation of longitudinal waves when the source of sound vibrates in air. When again the answer will start from here. When an object is made to vibrate, particles of the medium, that is air, are disturbed from their mean positions. Then sound propagates. Then answer will continue from here. Sound propagates due to vibration of the particles of the medium, that is air, when the vibrating object, remove this prong of vibrating tuning fork. In place of this you write down, when the vibrating object moves towards right, it pushes and compresses the air in front of it, creating a region of high density and high pressure. This region is called compression. Then start writing from here. When the vibrating object, in place of prong of tuning fork, write vibrating object. When the vibrating object moves towards left, the air in front of it expands, creating a region of low density and low pressure. This region is called rarefaction. When the object moves, in place of prong, write down object. When the object moves towards left and right, back and forth rapidly, a series of compressions and rarefactions are produced in the air. Thus, sound travels in the form of compressions and rarefactions in the given medium. One compression and one rarefaction together constitute one wave. Now, second question is, describe the factors that affect the loudness of sound. Now, factors that affect the loudness of sound are, number 1 is amplitude of the wave. When an object vibrates with a larger amplitude, a large amount of energy is transferred. So energy received by ears is more, hence the sound heard is louder. So loudness is directly proportional to the square of the amplitude of the wave. Loudness is proportional to square of amplitude. Number 2 is distance between the listener and source of sound. So loudness depends inversely on the distance between the listener and the source of sound. Lesser the distance between the listener and the source, louder is the sound heard by the listener, and greater the distance between the listener and the source of sound, lower is the sound heard. So loudness is proportional to 1 upon distance, or loudness is inversely proportional to distance. Next is surface area of the vibrating object. Loudness depends directly on the surface area of the vibrating object. Larger the surface area of vibrating object, louder is the sound produced. So loudness is directly proportional to surface area of vibrating object. Next is sensitivity of ears of the listener. Loudness also depends on the sensitivity of ears of the listener, and for different frequencies sensitivity of ears is different. How does pitch change in string instruments, wind instruments and percussion instruments? The stringed instruments have several strings of different thickness under different tensions. The frequency of vibrations of a string depends on the tension and thickness of the string. So, a note of higher pitch is produced by vibrating the string under high tension or by vibrating a thinner string under low tension. And in case of wind instruments, the pitch depends on the length of vibrating air column. So, to produce a note of high pitch or shrill sound, less number of holes are closed so that the length of the vibrating air column decreases. On the other hand, to produce a note of low pitch or flat sound, more number of holes are closed so that the length of the vibrating air column increases. In percussion instruments, there is a tightly stretched membrane that is made to vibrate by striking it. So the pitch of sound produced by these instruments depends on the size and tension of the membrane. More tight and small is the membrane, higher is the pitch of sound produced.